Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome once again to all of you to the physics classes. We have already discussed about work, energy and power and about some of the things about potential energy, and we have already discussed about work done in the case of constant force. And now in this class we are with one new example which indicates about the variable force. We have studied variable force is nothing but the force which varies continuously, and the work we are going to get, and that work done will be always integration of initial to final position and force into displacement. The work done for the variable force we have written integration of x into x final f of x dx. That is work done by variable force, and today we are with the example that is nothing but a spring. The work done by the spring is nothing but the force of a spring is nothing but is a variable force. Consider a spring in a smooth plane which is attached to a mass like this. Now what happens, you are going to extend it. Say for example this is x is equal to 0. You are going to extend it means, say this is x is equal to xm plus xm maximum. I can extend it. I can also compress it, no, to this. This becomes x minus x maximum. The maximum compression in the case of negative, the maximum expansion in the case of positive, right? Now what I can say, there is a spring force. It is found that, I will erase this, you have to remember this. I write that the spring force is nothing but variable force, no? The same force you are not going to apply here, little more and more you are going to apply. So same force you are not going to apply, little more when it is compressing. So spring force, whatever it is, variable force. But how you will find out the spring force? The spring force is nothing but opposite to that of the applied force. I am applying the force, spring is constantly pushes me in the negative direction. I am going to expand the spring is constantly pulls me towards the compression, right? So the spring force is opposite, and that spring force I can write down which is directly proportional to the distance. As I extend this, spring force increases. As I compress it, spring force increases. Like that. It is directly proportional to the displacement, so that I can write down spring force which is equal to minus kx, where k stands for spring constant and minus s stands for, since the spring force is negative, because I don't know the spring force, I am going to apply my force so that I can calculate the spring force. What I am going to apply the force? Same force, no, I am going to get back from the spring, right? So this is the first case I can write down, this is the second case I can write down, this is the third case I can write down. Now it is x is equal to 0, spring force is equal to 0. Spring force is equal to 0. Now force applied by you is positive, but what is the displacement? Displacement is positive. So x is equal to positive, but what is spring force? Spring force is negative. What is here? Displacement in the opposite direction. X is equal to negative, but spring force is positive. Force will be in the positive direction. It will pulls you or pushes you, yeah, here it will, here it push, it will pulls in this way, no, like that you can write down. So now what is the work done? So SI unit of spring constant, K is spring constant we are going to call. So if I write down K means how much? K is equal to F by X, no. What is the SI unit of new force? Newton. What is the SI unit of distance is meter. So it is Newton per meter, that is K, Newton per meter, no. Now we want work done by the spring force, work done by the spring, that is nothing but it is a variable force. So x0 to xm, I am going to write down x is equal 0 to xm, any one of the case I am going to consider, any one of the case I am going to consider. So f of x dx, but what is f of x? F of x is nothing but integration of x naught to xm minus kx dx, no, minus k is constant, integration of 0 to xm x dx. What is integration of this? So integration we didn't do, right? So I will tell you, integration of x dx means n means that is nothing but x to the power n plus 1 divided by n plus 1, okay. Differentiation is different, integration is different. This is called integration. So if I write down here means what I am going to get? Minus k, x to the power 1 is there means x to the power 1 plus 1 is 2 divided by 1 plus 1 is equal to 2. From where to where? From d0 to xm. How I have to apply the limit? At the place of x I have to put upper limit, at the place of x I have to put lower limit. So minus k will be remain same, x m square by 2 minus xm is 0 by 2, that becomes 0. So that I can say that kxm square by 2, that is the work done by the spring force, and it is negative, that is the work done by the spring force. So work done by the spring force is negative, that is kx square by 2, kx square by 2. Then what is the potential energy? What is the work done by the external force? I am going to compress it, spring force will be in the opposite direction, that work done by that spring force is this. But what is the work done by me? That is positive. But the work done by the external force, this is not, okay. Not work done by the external force is Ws is equal to kx square by 2. Kxm square by 2, that is positive, no. Now we also know, I will erase this, work done, how I can calculate? Work done by the spring force, they will ask this derivation, okay, for 3 marks they will ask, till here. I can write down the graph, isn't it? How I can calculate the work done? I can calculate the work done by drawing the graph force and displacement, after that finding the area under that we can find out, no. So now I will do force, displacement, force in the negative x-axis, displacement in the negative axis. First one is 0. Next what I am going to do? Spring force is negative, spring force is negative, but the displacement is positive. I will get the graph in this way, right. So what is F? Fs is equal to minus kx. Now here force is positive but the displacement is negative. I have to get this area or else I have to get this area, so that I can find out the displacement. So area is nothing but half into base into height, area of the triangle. No, I'll erase this. Area of the triangle is nothing but half into base into height. Half into base into height. So area is nothing but work done, which is equal to half into base into height. So any one we are going to take half. Base is how much? Xm. No, half into base into height. Height is nothing but Fs. No, Fs. So half into minus Xm. F-axis means what? K into X. No, that we have written. Okay. So you can write down that is half Kxm square. That is work done by the external force, work done by the external force or the spring force. Spring force is negative. Okay. So here it is negative displacement, force is some value, no, some value. Also you can get in that way. Okay, that is nothing but force into displacement. In that way we are going to get. If you consider the area means we are going to get in this way. Like that also we can make out, that is force and displacement. So this is what about to work done by the spring is. Work done by the spring is also from the graph you can find out, also from the variable force notation also you can find out. The students, we were talking about work, energy and power. So we have already discussed about what is work, and we were talking about example of variable force, and that is nothing but a spring. Spring is an example for variable force. That is, it is not a process of constant force. A spring is attached in a smooth plane, it is kept. Okay, now we are going to pull it and leave it means it will oscillate, right? It will oscillate. And if you connect it in vertical in this way means one mass is there, you will pull it and leave it means it is goes on oscillating. That is one thing. But another thing is that slowly if you pull means you are going to apply little more force and more force. Why? Because as more extension you are giving, the more rapidly the spring is pulls you in the opposite direction. That's why always the spring force is the opposite force to the displacement, right? And what we are going to write down, the spring force is Fs is equal to minus Kx, right? Okay, and after that we got that the area under force and displacement curve which gives you work done. The area under force and displacement curve gives you the work done. Now if you write down the graph, that is nothing but in this way, the force and displacement, that is positive x direction, negative x direction. The positive spring force, the negative way the spring force means extension, compression, extension, compression, in that way. Again if you have a doubt means what is that negative side force means, I can tell you, see, this is x is equal to 0, this is plus x, this is minus x. Now the object is here, it is freely left. Now you are going to compress it means spring force is in opposite direction, that is in positive direction, but you are compressing it, your force is in this direction, displacement is negative. No, why this we have put spring force is always opposite to the displacement, that's why we have put negative. Okay, now we can write down for the extension. Extension means in this way you are going to extend it, the displacement will be always positive, the displacement will be always positive, but the spring force is in opposite direction, the spring force is negative. If the compression means in this way you can write down the force and displacement. Okay, the force and displacement curve. So force is this much, you can get this area, you can get this area, no? So half into base into height, area means which gives you the work done, area which is equal to work done. Force is nothing but Fs, displacement is this much, force is nothing but K into X. Okay, say for example you are going to write down this means, okay, displacement is positive, okay, the force is negative, so Kx square, so half into base into height, isn't it? Half into base into height, half Kx square negative we are going to get, half Kx. In this way if you take means, same way you are going to get minus, so this is nothing but the work done by the spring force, okay, half Kx square. You are not supposed to put for the force negative, already you are given that is negative force or positive force, so this sign you have to put, okay. So here means this one is positive but force is negative, here means the force is positive, displacement is negative, like that. One or the other way, one negative sign you are going to get, and that negative sign indicates that work is done by the spring force in the opposite direction. That is what we can arrive the expression for the spring force. Okay. Now finally if I write down means, what is the expression I am going to get? Finally, the work done is same, though it is compressed or extended, or for the extension the work done is always same, so we can write down that work done by the spring force is how much? How much? Half Kx square minus half Kx square minus, that is the work done. Now maybe it is for the compression or rarefaction. Now we have given a spring in such a way that in this way, right, in a smooth plane it is connected. Now this x is equal to 0, this is the x maximum position, this is the x minimum position, or minus x plus x I can write down. Now how I can calculate the work done? Say for example I am going to pull it in only one direction, no, that is work done, this is just one way we are going to get, okay, but what actually it is, work done in the variable force, no, work done in the variable force. So work done in the variable force is how much? X initial to x final, f of x dx, no, f of x means minus kx dx from x initial to final, no, x initial, say for example here, final means I will extend, I will bring here. What is the work? I have done some work, but that is doesn't we not needed for us, or we are not concentrating on this. Why we are doing work? To find out the spring force, that's why we are doing work. Same as the spring force I have to do the work, no, otherwise how I should know that what is the force of the spring is. The more and more force I am going to it, same repulsive force, resistive force, restoring force is obtained there in the spring. So this is what we know, that is minus kx square by 2. This is nothing but the integration. In the last videos we have done that x initial to x final. Now what I have to do? Same way in the last videos we have considered x is equal to 0 final position, initial position, no, here x initial generally we are going to write down. So where x is there, upper limit you are going to apply, where x is there, lower limit you are going to apply. So minus, let it be there itself, that is kx f square by 2 minus kx I square by 2. So minus multiplied you are going to get kx f square by 2 minus plus kx I square by 2. So I can rearrange this. So work done by the spring is nothing but kx I square by 2 minus kx f square by 2. Okay, since it is negative, initial minus final value you are going to get in this way. So that is the total work done. In that way also we can write down. Now I will give you a scenario in such a way that I am going to erase this. This is the general expression once again we have written, okay. So where x were considered as 0, x initial were considered as 0. Again x initial if you consider 0 means this becomes 0, x minus kx square you are going to get, no, minus kx square you are going to get. Now next what you are going to get? Now if suppose what I will do, I will give you a scenario in such a way that I am going to give you a scenario in such a way that spring is connected. This is x is equal to 0, okay. Now what I am going to do, this is the initial position itself. Now what I will do, I will pull this spring till here and I will get it back and I will keep it here itself. Means if suppose, you have to write down, if suppose okay, spring is pulled from the initial position to the final position and it is allowed to go to its initial position, then work done is how much? That implies x initial is equal to x final, no? X initial is itself is x final, no? It's extending and come back again. Then work done which is equal to how much? Kxi square by 2 minus Kxi square by 2 which is equal to 0, means there is no work done. What is the meaning of this? What is the meaning of this statement? What we have considered, the spring is coming back once again to the initial point, okay, coming back to the initial point. Then what is the case? What is the thing? Work done is 0 we got. It's meaning that work done is depends only on initial and final points for the spring. Work done is depends only on initial and final points. If suppose it was depends on path, you would have got some value here while pulling and pushing. Since it is depends only on the initial and final points, we can make out from the equation there is no value, means that is a conservative force. The spring force is a conservative force, okay. That is what we have proved here. They will ask you prove that spring force is a conservative force. No, what we are going to do, we are going to do this and after that we are going to say that if it is allowed to expand and left back to its initial point, then we are going to get 0, means we conclude that work done by the spring force is depends only on initial and final points, and hence the spring force is a conservative force, and hence spring force is a conservative force. Now what I can do to find out? So in the case of spring force or whatever, the force which is conservative where the mechanical energy is conserved. If the force is conservative means the mechanical energy is conserved. Now what I am going to give, I am going to pull it and I leave it, it will going to oscillate. No? How it will oscillate? It will come back to the extreme position. I will call it as, this is mean position, this is extreme position, this is also extreme position. So what happens? I am going to pull it and I will leave it, it oscillates, no, it goes on oscillating. So now I will give you a scenario, fast it will oscillate, I will consider some slow motion so that we can understand in an easy way. So what happens? spring will come to this, stops for a fraction of second, goes back to its here it won't stop, again it goes here, stops for a fraction of second, again come back, stops, goes like this. So means that in the extreme position it stops for a while, in the another extreme position it stops for a while, but in the mean position it's never going to stop. Means that where is the velocity is maximum, at the mean position its velocity is maximum, in the extreme position velocity is minimum, or I can consider it as 0, Now what is the why we are considering that, why we are doing all those things? It is for simple that since we understood that this is a conservative force, and we understood that where in the conservative force is there, mechanical energy is conserved. Now what I will do, I will pull it and leave it, means it oscillates. The maximum becomes, one energy becomes maximum here, that is potential energy. One becomes maximum here, potential energy. Kinetic energy becomes maximum, potential energy become maximum. In between, kinetic energy also, potential energy also there, no? That we have studied, no? So all the kinetic energy is converted into potential energy at the extreme position. All the kinetic energy is converted into potential energy at the extreme position. Till that exchange of kinetic energy, potential energy, exchange of kinetic energy, potential energy, exchange of kinetic energy, potential energy takes place. No? That is the thing. Now, in the case of extreme position, what is that? Potential energy is maximum. Potential energy means what? Okay. Whatever the work I have done, it will be stored as potential energy. As soon as I leave, it converted into kinetic energy and again becomes potential energy, converted into kinetic energy, becomes potential energy, converted into kinetic energy, becomes potential energy, converted into kinetic energy, becomes potential energy. In that way it varies. Right now, what is the expression for the potential energy at the extreme position? That is nothing but half k x m square, no, maximum, that is the potential energy I can write down. And what is the maximum kinetic energy? What is the maximum kinetic energy at mean position? That is nothing but half m v m square maximum. So what is the maximum velocity a spring can attain? That is cancels everything. We want this Vm square, which is equal to, so k x m square divided by m. So V maximum is equal to square root of k by m into x. Square root if I have taken, that is the maximum velocity I can attain. But see, when this spring is oscillating, this block is oscillating, here maximum velocity, 0 velocity, maximum velocity, 0 velocity, maximum velocity, 0 velocity, maximum velocity, 0 velocity. But intermediate point is there, no? Intermediate point where x is equal to x, some value, okay. What is that? At intermediate point, same, right? Same, no? We can also write down potential energy k x m square is nothing but it is the sum of potential, here only potential energy, here only kinetic energy, but here it is potential energy as well as kinetic energy, because all of the potential energy goes on converting kinetic energy, goes on converting kinetic energy, goes on converting kinetic energy, finally it is converts completely as kinetic energy. Again this kinetic energy converted into potential energy, potential energy, potential energy, completely potential energy. At the intermediate stage there were two energies were there, that is total external potential energy at this point A, B, C, that we have calculated, no? in the same way, that point which will be equal to half mv square plus half kx square. This equation we can write down, and hence this is about the spring, and at the last we are gonna write a graph for the spring. So how I can write on the graph? Suppose I said that we have in this way the graph. This is positive x maximum, this is negative x maximum, and this is maximum, this is total energy, okay. This is x is equal to 0, mean position. Now at the x is equal to maximum, who is maximum? Potential energy is maximum, but kinetic energy is 0. Kinetic energy is 0. No, kinetic energy is 0 here. Increases, becomes maximum. Decreases, becomes 0. So kinetic energy in this way I can write down, no? Kinetic energy. But what happens at the extreme position? At the extreme position, potential energy is maximum, kinetic energy is minimum, and potential energy is maximum at this plus extreme. So I can write down the graph, no? I can write down the spring here, no? Don't write down the spring. So like this, no? I have extended and I have completed. So in that way, this is what the graph, potential energy, this is what the graph. So this graph they will ask for total value. So this is total potential energy plus kinetic energy. This is total potential energy. Kinetic energy means K, potential energy means V. Okay, total energy. Graphically, the mechanical energy of the spring can be written as like that. Graphically, the mechanical energy of the spring can be written in that way. So that is very important for you. That is very important for you. So for 2 marks, 3 marks, they will ask you the graph. 2 marks they may ask. Each and every step of the graph you have to write down. These are all just for the competitive exam it will come. So this is what about the spring is. Spring is the example for what? Spring is the example for variable force. One more variable force, and it is a conservative force. Variable force as well as it is a conservative force. Spring force is, and that is what we have studied in today's class. So this is much is sufficient for today's class. Some of the competitive formulas also there, okay, concepts are there, okay, go through all the concept clearly, okay. Thank you very much.
Don't forget to like our video and subscribe our YouTube channel for all the updates.